అప్పుడే 6 మెంబర్స్. Hi guys, good evening. Welcome to day 5 session of AutoCAD Electrical. Hope everybody is able to hear me. Can I get a yes, please? Guys, can you all hear me? Thank you. Thanks for the reply. Yeah, I could see that most of your friends are joining soon. So before we start on with the session, right. Guys, is my voice clear? Hope everybody is able to hear it properly. Please confirm with a yes. No disturbance in the audio, right? Yeah, great. Good. Thank you. Thanks for the response. Great. Super. Right. Before your friends join, may I know your pass out years, guys? The people who are the respective audience on the class. May I know your pass out year, please? Okay. So I could say 28, 24, 26, 27. Okay, 27, 26. That's it? Okay, 24, 22 also. Okay. Okay, 24, 22. Okay. Right, 26, 25. Super, super. Great. So I have different set of audience from 2022 is I mean like the highest year I've got it, and 28 is the least year that I'm seeing it. So I'm seeing like pass outs of years along with the first year candidates here. I hope you're all doing great with the first session of ours, guys. How is it going with you? Are you all enjoying the session, guys? How is session going on? From the past 4 days, I think you have learned a lot on AutoCAD, correct? Right, guys? So you had a very clear, a clear picture about how CAD is being used and how is it important for an engineer to work with. Correct. Thank you, Shalu. You said it was interesting. Great, great. Thank you, guys. Thanks, Aditya. Super. So can we have a quick recap before we start on? Before we go on with that, I would like to introduce myself. I am Bhavya, guys, Technical Director for HIW. And today's session will be held by me, and I'll be hosting the session as well as taking forward in understanding AutoCAD electrical. Yeah, and let us see how it is going to work with. Shall we start on? So before we start on with the session, I just because we had many trainers and we had two different trainers before me, so I just wanted to understand how you guys are actually well with the content and what is that we are going to see it. So let us start with this. So I'll just write it as a 5-day masterclass. So I request all of you to please respond on the chat box. It would be easy for me to connect and then coordinate with you guys. 5-day masterclass on AutoCAD electrical. This is the title that we have given, and we will just try and understand what exactly we have learned, guys. So according to you guys, what was taught on day one, guys? Somebody who's here, I hope almost all of you are here for 5 days. May I know who has understood what exactly we have done on day one and what is that we have learned on day one? Commands. On day one, we learned commands, Chinmay? No, we didn't learn on day one. Okay, we learned about introduction to AutoCAD. Good, great. AutoCAD intro. Okay, what is AutoCAD? Importance of AutoCAD. Super. What else we have learned, guys? Okay, we've learned about benefits, introductions. Okay, great. What all we have learned? That's it. Career opportunities. Super. Right. And we've also learned where exactly AutoCAD is being used. So I would say simply we spoke about history of AutoCAD. I would say that. And then life before and life of an engineer before and after AutoCAD. Is it right? Yes, yes. Super, Snehi. Thank you so much for your response. Right, right. Correct. So this is something which we have seen so far, and we are talking about this. The history of AutoCAD, life of an engineer before and after AutoCAD, and then we have also understood where exactly the career opportunities on AutoCAD are being done, and then we have also understood what are different types of drawings that can be drawn in an AutoCAD, guys. I think Madan sir, the day one was held by Madan sir, or he has given you a greater exposure on what exactly day one is being held on and how it is being considered, right? I'll just write it on the top just to have a clarity. Okay, so people who missed on my on the sessions of first, at least you will have a clarity like what is being taught on it, and then we will go forward and how HIW actually plans their master classes to get and to empower engineers to understand how the career would be there in this segment. Okay, so day one we saw history as well as their benefits and career guidance on AutoCAD. If we learn AutoCAD, how and what exactly we do it, and we've also seen multiple drawings, I would say starting from SLD. Okay, we have seen some panels, and we have seen some of the schematics, how exactly those will be there. We have seen some solar layouts from Madan sir, from his expertise and from his experience. We have understood like how the drawings would be there and how it has to be drawn, guys. Correct? And then we have seen from day two, okay, which was held from day to day four. Manjunath Kulkarni has taken the session. And day two was what was on day two, guys? What did we document day two? Super, super. Thanks, Saujanya. Thank you for following us. Right, we have commands and we have done some alphabets using those commands. I hope that was very interesting, guys. Right? So I think we have seen Faima Shahzur Sheikh. Sorry if I've pronounced your name wrong. Yes, we'll look into it. Don't worry on this. You can please put in today's comment section in the feedback that you couldn't fill the link on first day. We will consider your request. Okay, commands with all alphabets. How was it, guys? How did you like the concept of learning a simple things into technical aspect? Right, alphabets with commands. Wow, I feel it's something which we could consider, right? Maybe in HIW we generally try to teach you guys the concept in various segments as in part, and we always try and see how the segment would be also there and how the context will also be considered, guys. Hope everybody is able to see my screen as well as thing. Hope everybody's following me, guys, and it is visible, it is audible, and it is clear. Yeah, right, right, right. Great. Vijay, we didn't yet learn AutoCAD electrical with commands. Yes, we will learn about it. People who have joined late, we are just discussing what we have discussed in the past 4 days. As today there's a change of the speaker in the session, so we just wanted to understand what you have learned in the past session. So I would say we have learned AutoCAD basics, and not all basics, but a part of basics, and especially the command segment, right? And we understood like how different commands are and how those commands to be used and how to operate those commands to draw the drawings or anything that you want to draw it. AutoCAD is such a good application where it is an user-friendly software, guys. Just like your WhatsApp, where you can type it, and with minimal network also your WhatsApp runs, right? Similar way, your AutoCAD is also very, very easiest and simple respective software where it is easy to understandable and easy to implement the commands also there, right? That's on day two. And then what did we learn on day three, guys? What did we learn on day three? Okay, good. Simulated solar SLD of 200 kilowatt. Good, Yuvraj. Single line drawing. Good SLD. Good, good, good. Yes, right. So we've learned SLD. SLD is what, guys? Single line drawing. Can somebody define me what is single line drawing from AutoCAD if you have understood? A single line, I mean, like a simple definition of single line drawing. How do you define a single line drawing, guys? Good that the name only suggests that it is single line drawing, but how exactly you talk about single line drawing? Overall equipment used in the site. Okay, Snehit. Define our electrical system. Good. Good. With the help of single line, we can draw it overall equipment. Guys, people who are questioning about the certificates and all queries, we will take it in the last, guys. Please, I request all of you, please not to deviate from your technical content. That's a very kind suggestion, request to everybody. I request all of you to please wait until we move forward out of the technical content. We'll have set 5 minutes of time on understanding your queries regarding the feedback links and all. We will surely come back to you. Okay. Shalu and all others. So I had some questions. Jai says define electrical system. Good, Jai. Snehit says it is overall electrical in the site, equipment in the site. Vaishnavi says it's with the help of a single line. We can draw it. Okay. Good, Vaishnavi. Vijay says it's a solar diagram, ma'am. Okay. How do you define a block diagram and a SLD, guys? I'm just trying to connect with you guys. That's it. I'm not trying to waste any time. You will get at least few new points from the discussion. I will try. You can trust me and you can believe in me. Okay. So what are we talking about? We're talking about Femina says that it's a diagram which represents the system with help of symbols. Okay, great. A schematic with correct measurements and precision. Okay, Saujanya. Not completely accepted. Basic design of the site. Okay. Akash is simplified version of actual field. Okay. A diagram is represented with the help of symbols. I got you, Shahajasur, sorry. Yuvraj, single line diagram with a specification specified of an electrical power system. Okay, Yuvraj. Block diagram, somewhat basic. SLD about somewhat deeper to understand the client. Okay, Snehit. Exactly where exactly we draw block diagrams and where do we see SLDs, guys, according to you? Block shows connections of all our connected equipment. Okay, not completely accepted, Jay. Sorry for that. We have points from Mokshita. Okay, Mokshita, you can give it in main chat instead of private chat, requesting you to that. Okay, so where are we? Block diagram is used in only control system theory. Good, Yuvraj. Accepted. Uh, Jaivir says it is in substation. Okay, what is in substation, Jaivir? You're talking about SLD or in block? Logarithm used in control system theory. Okay, Vinith. Is it Googled answer? I somehow see it like that. Is it? Vinod, Yuvraj? Is it? You can accept no worries. Good, good. Thanks for your honesty, Yuvraj. Okay, Yuvraj. Good. A simplified symbolical representation of electrical power system is SLD. Okay. Shabana says block diagram are used to understand systems. Great. Okay. Great. Right. Super, guys. I'm getting a repeated answer from this. Okay. You try to get an answer from Google also. Maybe the Google also will give you similar set of answer. Okay. Akash says it's a flow. Which is called as flow, Akash. Vaishnavi says it's also uses schematic for our practical manuals. Okay, after we understood what is SLD and what is schematic, still we have that confusion. So we'll try and understand how SLD is different from a schematic, how block diagram is different from a SLD and all those segments. In electrical, we will not generally refer to block diagrams, guys. We will always try and talk about in terms of the uh, SLDs, schematics, or key line drawings or layouts. Okay, majorly we talk on this in this terminology in most of the electrical aspects. We will not purely talk about block diagrams. As somebody said, it's in control system, yes. But to define the flow of the system, okay, we use block diagram like a power plant. If you remember, people who have already into your third years or second years, who have done your SEF 2-1 and all, who have finished your pass outs, okay, there we see that your flow of power in the generation process, a process is being defined or being explained in a block diagram, guys. Okay, wherein you talk about your SLD, okay, which is called as single line drawing. Single line drawing, as most of you said, is surely to represent the respective electrical power system 100% using a symbol. We notate the respective any equipment with certain symbol. Okay, and then that symbol along with specifications, you mean specification in terms of the rating of the equipment. We will not even miss a minute equipment in the SLD, and we make sure that it is being given. Even as smallest terminal is being considered in the SLD, guys. So single line drawing is something where you look into it and you will understand how the system power flow is being considered, okay, from top or from bottom. And then you will also look into the segment wherein you will understand each and every equipment's rating individually. That is single line drawing. So I just define it for you. So in second day, we have learned single line drawing of a solar power plant, which is of 200 kilowatt peak. And if you have observed the SLD, which is already been shared in the uh, WhatsApp group that you are joined, most of you have joined, where you see that each and every equipment beside we write the cable designations, we write the inverter rating, we write the module rating, okay. We try and write each circuit breaker's rating. In SLD, you see every equipment has its own rating, guys. So I define single line drawing. If you haven't mentioned any respective ratings of the equipment in SLD, then SLD will not be complete SLD, guys. SLD is always completed when you have considered the respective ratings of the equipment that are used in the or about to be used in the respective system. Okay. And coming to your solar PV plant designing, if you have seen the power flow of the respective from the module till the evacuation, where from the inverter till to the connection to the grid point, the connectivity is being shown by Manjunath. I think we all learned a great thing into it, talking about the symmetry. And in the first class of ours, we try to made you understand how AutoCAD is being used, guys, by just drawing simple alphabets, because we know how to draw an alphabet. Now, drawing the same thing into an AutoCAD will give you as a clear picture, like how AutoCAD is being processed and understood to draw certain elements which we already know it. Then coming to your respective single line drawing, we have understood how electrical components or electrical equipments are being drawn. You take a breaker, you take a transformer, you take a module. Okay, you have taken a CT there. Okay, you have taken a meter, you have considered a relay there. Right, the many things that are being considered in a solar PV plant SLD which we have designed. Then coming to day 4, what you have learned on day 4, guys? What is that we have learned on day 4? Okay, we've learned a motor circuit. Okay, Yuvraj, I would like to tell you one small correction from your replies. We in AutoCAD we do not simulate, Nana. The point is we will not consider the AutoCAD as a simulation software. AutoCAD is purely a drafting software. Drafting mean a simple correction or a rough thing, and until you make it into an export of it, it becomes final. So people who are working on the CAD are called as draftsmen. An engineer also does work on it, but he does purely drafting into the system. He will not individually work on the concept of it. I hope you're all with me, guys. Anything that anybody has any issue with my voice, or am I speaking faster? You can please let me know, because Manjunath will take it very slow and steady. So if I'm rushing, you can let me know, because I'm just repeating the past content. I don't want to waste time on the technical that we're going on it. Ma'am, okay. No worries. No worries, Yuvraj. Thank you for your reply. Great. Thanks, guys. Thanks for your response. So now we are talking about the day 4. So somebody said it is about motor circuit design. Yes. So Manjunath has designed circuit design, which we call it as a schematic design, guys. In the language of electrical, we refer to that motor circuit. He has drawn a power circuit there. Okay. There are different types of circuits that are being used in the schematic design also, guys. So we will see that once, and then we will go forward to the a different level in AutoCAD to understand AutoCAD electrical, which is the current trend in the electrical industry. Okay, there isn't people who are using purely in AutoCAD, and we also talk about AutoCAD electrical that we are going to discuss it. Okay, are we all clear so far? Now this last one, day 5, what we're going to see is talking about the schematic design in AutoCAD edit. Yeah, let us see and good to go with that. Clear, guys? Anybody who missed any session in between? So just a quick recap what you have learned. So I hope you have understood like how AutoCAD, we have understood what is AutoCAD and history of AutoCAD, how tough it will be there. Okay. And then we have understood what we have learned in past three sessions. That is your AutoCAD basics, and then single line drawing of with respect to electrical, and then schematic drawing as simple step level up. There is another level which we call it as layout. Somebody used a word called precision and measurement when I was asking about schematic designer. See, we do not draw any drawing like your single line drawing or your schematic drawing. Okay, in the with respect to your layout or scale, we call it as in scale, guys. We will not draw single line drawings or a schematic drawing with respect to scale. Okay, we tried the drawing to be drawn with symmetry and with proper proportions in terms of the, see, you can't draw a big CT and then a small module, right? So you try to compensate the size of the equipments symbols in the AutoCAD with respect to your requirement, like on what scale you're trying to draw it. You can't draw a big number of, like for example, I'll just try to draw it on the, so I'm drawing a transformer. And if I draw a CD bigger than transformer, sorry. If I draw a CD bigger than transformer. Okay, this is not called symmetry. Okay, this is not called what we look into it. So what we suggest you guys is we will try to draw, sorry, we will try to draw something with respect to proportionation. Just trying to show you two symbols, guys. Okay, right, so let's get started with what we are gonna learn. Right, moving forward. Hope everybody is able to see my another screen, guys. Yes. So now we will just talk about the SLD here. Hope everybody is able to see my screen. Please confirm. Yes. Thank you, Padmesh. Right. So we are seeing a simple SLD, guys, where we'll understand how the system will be there. Now you can see there is an arrow mark on the top referring to that this arrow mark refers the power flow is from bottom and the connection is coming from bottom. Okay, we will just see some SLDs with respect to my perspective because I believe electrical engineering is perspective engineering. Okay, current definition of mine could be with respect to Ohm's law. Current definition of yours could be with respect to charge. Somebody's with respect to voltage, somebody's with respect to resistance. So it could be differed in different various and the fundamental is same. So I believe, and so I just wanted to tell you like because my session now is going to talk about purely on schematics and it is really a level high. And I saw that most of you are pursuing candidates who has no idea most about switch gears or the connections of the equipments or how the elements are being designed or equipments are being considered. So considering that into criteria, wanted to show you some basic fundamentals which Manjunath has already taught you on a good level. Okay, so we are talking about, and I hope everybody is able to see a spotlight on my screen, right? So now we will see how the spotlight is being considered. Okay, so let us see that I have a bottom arrow and then you can see that your respective supply is coming down and then you can see there is an incomer SF fuse, TPN fuse unit, switch fuse unit where you can see it, okay, of 630 or 400 amperes and then you can see there are indication lamps which are called as ILS indication lamp, red, yellow, blue. Okay, then there is a 2 amps uh, fuse unit and then we have a voltage selector switch. VSS represents voltage selector switch, and we have a voltmeter there. Coming down, I see that the supply, whatever you're seeing here, the incoming supply is being measured and also being protected, guys. Every respective system in your houses also will have a breaker at first. So what we are doing is we are trying to understand how the system will be considered and how these are being considered into criteria. So you can see that the supply, whichever is coming here, is taking an input, and the input supply is being first measured. Okay, in case if there is an higher, then automatically this breaker will get tripped and the supply will not be given to the respective bus here. So before it goes to the bus or to the supply of the equipments of connectivity, you can see that you have a CT and the respective power along with the current. Both the kilowatt hour meter is an power meter, which you, or you call it as an energy meter. You look into it, where your current as well as your voltage are being measured, and both of them are being measured, and then it is being checked simultaneously to understand how much is the input coming into your system, guys. Now if you see it, there is a system that is being seen here. Okay, wherein you can see there is a 415 volts, three phase, four wire. 50 kA is the short circuit capacity. 50 hertz is a frequency. Aluminium bus bar is your respective bus bar. Okay, they have used an aluminium bus bar there. Now you can see that there are various loads connected. These are called as feeders in the general terminology, or you call them as load. Now we generally draw a simple arrow mark that represents this arrow mark like this. Okay, so now when I'm looking into this, here you see that I have an supply given, and there are fully automated star delta starters, okay, which you can see it here of 30 HP motors. Okay, 1 to 4. We have four numbers of fully automated start. FASD represents fully automated star delta starters. There are starters. Do you know what is starter, guys? What is starter? What is between energy meter? Those are voltage selector switch, Yuvraj. We call it as a voltage selector switch and ampere selector switches, where we try and understand how these are connected. Okay, I got an answer from Sai Krishna Maganti saying that starter is used to limit the starting current. Why do you get this high inrush current, or what is meant by this limiting starting current, guys? How do you define this? To control the starting current. Yeah, but why should we control the starting current? 2 point starter, 3 point starter, very nice. Somebody answered me a point of 2 point starter and 3 point starter. I request my team to not to post the messages about HIW. Could you please give little time for us? Yeah. So Yuvraj said 2 point starter and 3 point starter. Okay, great. Um, because it will damage the equipment if it will be high in the starting condition. Good Famina. Tejaswini says because it's high enough to start to limit the start current. Okay, excessive currents, winding protection, super. To protect the motor winding, great. To protect the equipment from Saujanya, it says. Okay. Uh, okay. And then we have protect the motor from high current. Super, guys. Why do you see that high current? Somebody said inertia word. What is meant by inertia, guys? At start, huge amount of current will flow to the motor. Super, Sai Krishna. To protect the motor winding, excessive currents from Nimmala, Reshma. Okay. Okay. Tejaswini has replied about inertia. What is inertia, guys? What is inertia? Guys, can you all hear me? Is my voice audible? Sagar, could you please check with your audio connection, guys? It is audible to everybody. Sagar, please check with yours. Inertia means weight. Okay. Not completely accepted. Okay. Thank you, Satyendra. Right. So we were asking something about inertia. Okay. Now I have a simple question, guys. Would you like to answer my question? Before, as soon as you get up from sleep, okay. Okay, Ashrita, thanks, Ashrita, for the answer. As soon as you get up from sleep, how much time do you actually take to wake up from the bed? Durga Bhavani, no. Inertia means normal rotating speed. No, actually. No, no. The question is the moment you get that immediately you get that क्या बोलते हैं उसको ये होश निद्रట లేవడం ని ఏమంటారు? Okay, I'm speaking in Telugu just to make you people understand to get my question. As soon as you're on the bed and you got an alarm, okay, and you woke up, okay, what how much time do you take to get up from the bed, put your leg, sorry Pravin, 5 to 10 minutes, so very less time, yeah. 10 to 15 minutes, okay. Kritika says 5 minutes, maybe 10 minutes, okay. Good, so good, Snehit. I accept your point according to the usage of mobile, okay. Now, the moment you wake up, okay, just wake up from your sleep, not from your bed. No, you're not getting up from it, okay. Sleep once again, okay. Good, Abhilash. Nice habit, okay. So now when you look into this, what is happening there? You try to get up from the bed. The moment you're trying to give that energy to your body to wake up from sleep position to sitting position. Okay. Okay, you take the support of your hands or you get up from your bed. Okay. What is happening? Your body should pump in some more little energy to your body to get up. You sit down and then after 1 hour you're trying to get up. Okay. Okay, your body is into one state, which is called a state of inertia. Inertia could be not only with respect to weight, it could be with respect to the state of the equipment. Now your body is turned off, sorry, during sleep, and your motor is switched off when it is not in use. Suddenly you start a motor should get that energy to actually run at a normal speed. Guys, you're all with me? Lack of energy is inertia. Okay, to some extent, not completely, right? So now what is happening? People who didn't understand what is inertia and why motors have high starting current. I'm just trying to answer that simple question, guys. Why we need require starters is the connectivity to that question, okay? So tendency to change its motion. Correct, Prem, you're right. So what is happening? Your body or the motor, I'm comparing your body with the motor for time being, where you will understand that your motor will need some more energy to actually rotate in a normal point. In that position, what happens? Your motor tries to drag in lots of current, guys, from the supply because it is not storing anywhere. Motor doesn't store anything, but it has some back EMF present because of the state of the motor that you have offed yesterday or you turned your motor off. Okay, along with the back EMF, if it is not sufficient to run at a normal speed, it tries to take up some respective energy from or the supply from the power. Okay, power supply. It's like more power from the supply. Sorry for the statement. Or it'll take more supply from the power supply. In that case, what is happening? Your motor will try to, it is not understanding how much it requires, correct? So it takes up lots and lots and power, which might damage the motor windings also. Okay, sometimes we try and get up. Sometimes we try and get up from the bed, and then suddenly you are trying to, and you didn't get that support to put your hand or base your hand properly on the bed. Then you might get some cramp in your neck or in your back. It happens, right? It might damage you when you're trying to get up. In the similar fashion, your motor also, when it takes up lots of current, it might damage its own winding. Motor is not understanding at what point it has to stop. So that's when we call there is a high inrush current because it is all of a sudden entering into the motor, which could damage motor winding insulations. We try to halt the respective current at which the motor can take in the current. Okay, it has to stop. Kavya, you have any question? Sorry, you just raised your hand, so I just wanted to understand. Okay, so now what is happening? Your respective energy that is being taken, or your motor tries to take it into current. That in that case, your starter will try to limit the current at which the motor's winding will not get damaged, guys. In case of your 2-point starter or a 3-point starter in the laboratories, if you have seen it in your colleges, what happens? We switch on the respective switch. Okay, and then we use your starter from 1 point, 2 point to 3 point. If you observe the pointer starter in your college, in your laboratory, where you will see the resistances. where you will see the resistance is added in between 1 point to 2 point to 3 point. The resistance will cut down the respective current. And then by the time the current reaches to the motor will have a normalized current to start in that case. That is the respective use of the 2-point starter and a 3-point starter. The fundamentally same for the starters in case of your star delta, DOL, or your soft starter, or your VFD. Okay, variable frequency drive starters. There are many starters that are available in the market, guys. And currently, most of the applications are being used with soft starters or VFD starters. Minimal applications like your DOL starters and star delta are used for your most of the higher rating motor application starters also. So if you see, all these are industry used. Now the best example to understand the DOL starter is your pump motor in the house. Have you seen your pump motor? You will see one red button and one green button in the house. The bore pump motor that you see it for the water pumping from the groundwater. You see, you'll have two just push buttons. Those are called as push buttons, the red and green ones. Okay. The green one is for on and the red one is to off. Correct? So that is basically a simple DOL starter, guys. Very, very simple DOL starter. Okay, you can see here, I could see that there's a push button and a DOL starter along with an OLR. This symbol represents an OLR in other standards. See guys, uh, what Manjunath has shown you as in part of OLR, we had two respective circles like this as in switch opening and closing. Okay, that's an overload case in that case. And now here, whatever you're seeing is just an a rectangular, semi-rectangular wave like that. Yes. So that case, we got this is also an OLR here, which you see where my spotlight is actually moving in. So you can see this is in 16 amps push button. You can see it, and there's a fuse unit here. And then you can see it is being given to a DOL1. So likewise, this SLD is purely to supply, and it's a panel that is being given. Okay, this is basically a simple panel SLD that you're observing here, which is starter panel. Correct. So you can see that I have four fully automated star delta starters and then one capacitor bank of 50 kVAR. Okay, and then you have some SFU units used for spay considerations. And then if you want to take some supply from the power, you can take it from this units. And then you have your two, 1, 2, 3, 4, 5 different starters. Okay, we have again SFU units of this, and I can see 1, 2, 3, 4, 5. So I see 3 plus 4, 7, 8 DOL starters, 4 star delta starters, 1 capacitor bank, and 5 SFU units. Now, this is simple reading of an SLD, guys, wherein you can see each and every equipment has its current rating. 125 by 63 amps, 50 bar 5 amps, okay, 50 up to 300 amperes. Okay, you have a push button, you have a fast stop delta starter, so star delta starter, sorry. And then you can say capacitor bank. You see that every SLD will be mentioned with respect to the ratings. This is how the SLD is being mentioned. Now that was told on your day 3. Okay. Yes. And then we have, let's go to something called a schematic. So that's a star delta starter schematic, guys. You can see that here I have a four wire system, which is RYB neutral. I mean, like 3 phases, 1, 2, 3 phases, red, yellow, blue, and the neutral. Okay, so it's a 415 3-phase supply, but the system is 4 wire system. Okay, and then from here, what you're doing, you're trying to take an input supply. Guys, you're all with me. I'm trying to explain you a basic industry used DOL starter. Yeah. Yes, great. Good. Super. Thank you. Right. So now we are seeing that we have a fuse select switch unit. FSU represents fuse switch unit, where you can see you will have a fuse connected. We see most of it in movies where the villain tries to take off in serials. I would say the villain tries to take off the fuse out of the switch unit and the power goes off, right, during the any of the climax scenes and all. Then again the hero goes and keep it off, or somebody does that. I'm just giving you a good example where you can understand what is switch fuse unit, guys. Yes, switch fuse unit. Yeah, right. Next we have a K1, which is a contactor, guys. And then we have an OLR, right? OLR is overload relay, right? And then we see one, two, three. These are terminals, guys, right? One, two, three. We see these are nothing but your terminals that are being connected to the motor. And here you see the motor terminals also. We have given a power schematic. This is called as power circuit, power schematic of the respective connectivity. Coming to this contactor, okay. And then when you're looking into it, you can see that there is an other supply given to the system, which is called as control schematic. You see this left part, I'll just put an rectangular box to understand. This part, which you're seeing here, the red box which I've just drawn is purely the power schematic, guys. It is power schematic. Okay. And then the right part, which you're seeing it here, is called as control schematic. Correct, Abdul Mohit. It is power circuit and control circuit, right? So in schematic, we'll have power schematic and the control scheme. Control scheme is fully operated with respect to either single phase supply with respect to 230 volts. Some case it will be 110 volts where we take it as another part, or sometimes it could be DC supply also for the control schematic. Mostly it will be single phase supply taken from the main supply. As in, you can see that from the respective supply from here, I'm using my spotlight again. You can see my red arrow mark. From here, it is connected like this. And you can see that the supply is being given from the one of the phase and the neutral. Okay. So this control scheme, which you're seeing it here, right? Now you can see that there is an 2 amps simple fuse, okay, control fuse. And then there is a flag connected to this. Okay. And then you see that I have an overload relay and it has an selector switch, or it's a two-way switch that is being connected. It automatically, it's like a toggle switch. Okay, whenever there is a consideration, right? Guys, you're all able to hear me? Is it Sagar that has and everybody is not able to hear? Right. Correct, Yuvraj. It is a single. Now here in this case, it is not single pole double throw. Here the OLR will switch depending upon the current rating. Overload relay will sense. Relay is something which senses the right. So in that case, what happens? Your respective relay will take the sense the current, and if that it's beyond the limit of whatever it is being rated, then your respective overload relay will trip directly. You can see trip indication lamp. You can see trip indication lamp. Right, two-way switch. Right, Femina. Right, and then we have stop push button. Okay, which is an NC, normally connected, because to supply the power flow. So what I'll do is I'll just use an arrow mark to make you people understand in a better way, guys. So from here, the supply comes in. Sorry. From here, the supply comes in. It is going, and I see that there is no overload current. So the current is flowing like this. And then I see there is a stop push button that is being counted. It is connected. So the supply goes like this again to the bottom. And then I see there's an interlock connected between the respective K1 and your push button consideration. And then from there, you can see that there is an this is for future interlocking, guys. Interlock represents here for future interlock. In case in future you want to operate a motor with respect to or one dual starter with two different motors. Okay, in that case, you use your this future interlock consideration. And then coming down, you see the stop push button. Remote consideration if you want to connect it. These are remote. The shaded part is remote. That means it one will be near to the respective motor and one will be in the remote location. Okay, like you can connect the same motor pump in two different floors in the apartment for the pump consideration. Now that is called as remote consideration. And then from here you can see the power supply is coming down. And now let us suppose that we are trying to push the start push button. Now we are trying to push the start push button, right? In that case, what is happening? The supply. Now this will get connected and it connects like this. Then the supply goes down and you see that the coil contactor is a is an is a supply oriented switch, I would say, where when the coil gets energized, then only the contactor will operate. So the contactor here, the coil, whichever you're seeing K1, is supply oriented switch, I would say, where this coil gets energized. Okay, then only this contactor gets closed, or this contactor gets closed. Okay, you can't press the button and keep it like that until you want to run the motor. No, we push it and we leave it. We push the button and then we leave it. So continuously there is a supply which is coming in. So in order to make sure that the respective supply is in continuous, I'll make this contactor to connect. This is called as NO contactor, which is normally open. Sorry, I'm going little high end, guys. People who are not understanding, you can post your questions later. But please understand, it's just that I am pressing a button and there is some contact touching the respective terminals like this. Okay, once I leave my push button, but the contactor gets supplied. So the respective contact, whichever you're seeing here, becomes closed. The normally open system will becomes closed. I'm just writing as CL to understand as closed. And then you see that this contactor supply travels like this to the contactor, sorry, coil. And all the time until you disconnect the supply here, until you disconnect the supply here, your dual starter runs, your motor runs. Did you all understand this control schematic? Okay, and then you can see the same contactor, whichever you're having here. If it is closed, then the dual starter is on. If it is open, then the starter is off. Okay, please do not go with the respective real-time symbol indications on the screen, guys. Always the schematic is drawn in the off condition and red in on condition with respect to the power supply as just shown you. You're all understanding? Yeah, it is little difficult, but yeah, we will make it more easier because you need to take more considerations here. Yes, Abdul, you're right. You have considered that. Yes. Okay. Sure, you'll get the links in the community, guys. Requesting you to please let us finish this and then we'll understand it. Now that is something, and here we see there are something called as TB represents terminal block, TB1, TB2. Why is this ma'am speaking so much about this schematic that to today, and which is little high end, I know, but yeah, my intention in showing you this to make you understand what is the difference between SLD in a power circuit and a control schematic, guys. Okay, so far you guys have drawn wonderfully talking about SLD just in AutoCAD, and then you have spoke about the respective control schematics, right? Yes. So, but I just want you to give some info about how the control schematic is being considered, because the software that right now I'm gonna use needs all these pin connections, guys. Now, you see that I am very much particular about at what point actually my connection is being given. This respective supply connection is given to K1 or K1 side of your respective control fuse, 2 amperes, and K2 is connected to the OLR point. Okay. Now what is K1? What is K2? K4? Okay. What is this K2 again? K9, K10. Can you see this? All these here, K1, K2, K4, all these are called as ferrule numberings, guys. What do I refer them as? Ferrule numbering. I talk it as in ferrule numbering, guys. That is nothing but when a connection is given, okay, and you have to tell me, you can't say, ma'am, control fuse ke connection ke side. You can't tell that. Okay, you should always talk about the fuse point at which it is being connected. So every equipment will have a notation to its respective terminals, connectivity points. Okay, and every connection has a label to it, guys. And that label is nothing but ferrule number. Are you all with me, guys? Did we understand this? We understood this? Yes. Can I get a yes, please? Yes, guys. Everybody, please. Are we all clear? Great, great, good. I could see there are participants more than 160, and then I get only few S's. Great. Thanks, Tushar. Thank you, Roshan. Thanks, Vamshi. Great, great, good. Super, guys. So now this is ferrule numbering, which we just discussed. And then we also will talk about the equipment consideration. Whenever we are trying to give, see, generally the final motto is that uh, most of you have gone to apartments or we stay in apartments, right? Yes or no? Most of us stay in apartments, correct? Have you seen one big cement shaded or any uh, little gray shaded box with all lights in it and with partitions in it? Have you ever seen it? What do you call that? What do you call that, guys? Okay, you call it box. I didn't knew it. Okay, good, Abdul. It's called panel. Okay, it's called panel board. Super. Okay. Sunita wants a picture. Yes, I can. Just give me a moment. Just to give me a moment. Can you all see my Google screen? Please confirm. Can you all see my Google screen? Yeah, everybody. Have you ever seen such big things in your apartments? Yes. Right. These are called as control panels, guys. So now this SLD which you have, this schematic and whichever you're seeing will be like that only. Now, whatever the SLD we just saw it. Just give me a moment. This SLD which you're seeing, this will finally turn into a control panel. And we have just discussed about only the one respective DOL starter, that is this. Maybe all the DOL starters will be in the same fashion here. Okay. Now we also have delta starter, but I will not confuse you much because people have felt that only as in too technicality discussed. Okay, so I will just go little considering the set of audience present here. So that is single line drawing. And then we have seen a star delta starter, sorry, a DOL starter. Now we will see something called as uh, GA drawing. Can you all see it, guys? Does it look similar to the ones we just saw in the Google image? Yeah. Yes. So this is also being drawn in AutoCAD. There are many softwares that are to draw this also. Now this is simply an same respective one. You can see that you have an voltmeter, ammeter. I will just try to relate it, guys. Give me a moment. Okay, I'll use this thing. Okay, you can see two screens of mine. Yeah, right. So you can see there's a supply RYB here on the left using my spotlight, RYB here on the left, and this here also you can see RYB on the right. Okay. And then you can see 630 400 amperes breaker. Okay. You can see it here. Sorry, it's a fuse unit. Okay. And then you have a cable incoming from the bottom. Okay. Now coming to this. Then you can see there are four star delta starters 30 HP 1, 2, 3, and 4, which you can see it here. Can you see it? Yeah. So this is this, and then you also have this here, right? And then we have 50 kilowatt kVAR capacitor bank, and its respective capacitor bank has been designed here. And then you have your SFU 1 and 2. So we have given two respective vacant SFU switch cabinets to that respective segment. And then we have DOL starters, total seven. So one, two, three, and then again other 5 HP motors, one, two, three, four. Then we have 1.5 HP DOL starter one, and then we have two F250 amperes and 125 amperes SFU units here. You can see them on the left side. Please observe my spotlight, guys. It will be easy for you to get and connect with the respective GA and the SLD. Okay. Likewise, this is how you draw your GA drawing with respect to your SLD AutoCAD. Now, this GA drawing is also, which you're seeing here, is fully with the scale, guys. You can see the dimensions mentioned here. This is to the scale. The GA drawing is been done to the scale. You can see even the base plate details and the connectivities are being given very detailedly and understandable. Are we all clear so far? Can I get a yes? Great. Good. Guys, others? Lavanya, Rahul, Prem. Okay. Thank you, Jay. Thank you, Sheikh. Thank you. Thank you. Great. Super, guys. Now, what we will do is we will just try and draw the scheme that is Manjuna drawn yesterday. How much time did you guys, if anybody has tried to draw your if tried with AutoCAD with the SLDs or the schematics that we have given, what is the approximate time you guys took to draw it in AutoCAD? What is the time you guys have taken to draw it in AutoCAD? 3 hours. Okay, great, Yuvraj. 1 hour. Good, Bhanu. Any others who've tried? 1.5 hour. Good, good, Vinod. 3 hours. Okay. Okay, good. 30 minutes. Okay, 2 hours. I've taken 10 hours. Okay, Jay. Okay, super, guys. Super. It depends on practice. Good, Sunita. Yeah, but I know most of you are freshers, so I can consider your 2 hours, 3 hours, and 1.5 hour considerations. Yeah, good. 4 hours. Good, Hemalata. Snehit, oh, super. 2 hours. Okay, 3.5 hours, 2 hours. Guys, you've got a lot of patience, and I'm glad that you're stepping ahead and then understanding how the application moves on and then works on. I am really glad that you guys have practiced it, and if you have just put for the name and then that's okay, you will practice someday. But yeah, super. So 3 hours, 4 hours, yes. So now there is another software. Okay, I'll just uh, share another screen. Please wait for a moment. Okay. So the normal Autodesk AutoCAD, which you have seen it, which Manjunath has shown you, which he has drawn yesterday. We'll take this only into criteria. Can you guys see my screen properly? Okay, that's drawing one. I'll come back to this. Right. So this is super. He has just drawn a similar DOL starter here using a motor along with his OLR terminals, contactors, and then fuse units along with the uh, a control transformer with respect to supply to its coil and other segments. He has not given any tagging. That's okay. We couldn't have that time yesterday to work on that. Okay. Yes, yes. It takes more time to find drawing. I lost it by zooming in or zoom out. Z enter, E enter, or A enter, Yuvraj. There's a shortcut. Zoom, Z represents zoom. Okay. And then you press A, where you will see the drawing exactly where it is there. Okay. This is drawn with us in yesterday's session. Okay. Right, right. Okay. Z enter and A enter. Okay. I'm somewhere here. I'm just pressing Z enter and then A enter. So whatever I've drawn it, you will see the all drawing that is being drawn on my model space. Okay. Now this drawing which you have drawn, Okay, this is just in AutoCAD, guys. I would like to tell you one point here. AutoCAD, whichever we have used so far, is a generic AutoCAD designed for all set of engineers, guys. AutoCAD, which you have seen so far, or the basics that we have spoke about, or then the generic software, is a generic software designed for architects, civil engineers, mechanical engineers, okay, electrical engineers, electronics engineers. Okay. There may be people who will also use it, the designers and all those. Yes. So here the commands that we're looking at is a generic software, guys. But AutoCAD has, after so many years, almost like uh, AutoCAD Electrical has been launched from the year of 2015, I guess. Okay, 15 plus. And where you can see that your AutoCAD Electrical. Now AutoCAD has launched separately their own relevant system applications. Okay. Architects has their own software. Architects, the normal one is being used by civil. Mechanical, you have separately a mechanical one. Electrical, you have AutoCAD electrical. There's another one with respect to electronics also. Okay, where they design their PCBs and all those segments. So there are various separate segments in AutoCAD that are being used, guys. So let us see how normal AutoCAD and AutoCAD electrical is differed. So I'll write it as in one side as an AutoCAD. Okay. And in AutoCAD, you can see that you can draw a normal line. Okay. Or you can draw anything in AutoCAD. Okay. Wherein I will talk in terms of SLDs, schematics, sorry, layouts. We just saw a GA drawing. GA reference general assembly drawing, nothing but a panel layout, panel drawing. Okay, general assembly of a panel, right? You can draw anything in AutoCAD, guys. When I'm talking with respect to electrical in a generical software, electrical related drawings. Okay. When coming to your AutoCAD electrical separately, I'm putting it in red color, guys. The name only suggests as an AutoCAD electrical, or most of you know it as an ECAD. Electrical CAD, nothing but ECAD, guys. Okay. So when you're looking to this respective application as in part of ECAD, we have uh, I'm sorry, various different, and ECAD is designed for schematic design, guys, or panel design. There are various n number of related softwares like your AutoCAD electrical, naming them as an ePlan, SolidWorks electrical, and then you also have mm, E3. Okay, ETAP is not a schematic design software. Okay, and then we have these many softwares, other different softwares. MATLAB, no. Revit is also not a schematic design software. MATLAB is basically a scheme design one, but with respect to your electrical components. NXCAD is used by mechanical. Yes, we do also have NXCAD electrical, which is used for locomotive design and all these segments also. Okay, so now when I'm coming to your schematic, Akash, are we not interested into this? We'll take I'll make you guys go through the schematic design. You just bear with me for 15 minutes and then we will give you the feedback link. Okay, please bear with me for 15 minutes. We'll go back to the software. Okay, so I'm just giving you a detailed understanding about the schematic design and the panel designing, wherein we will understand how the schematic design is being considered. So here in this case, when you're looking into it, a schematic design in this portion, you will have an predefined or a database of electrical. Okay. And then you also can generate, generally what happens is the list of equipments, I will call it as an, or equipment list. Once you have drawn a schematic, okay, you can create your own symbols. Okay, you can directly create a whole schema. Okay, let us go back to application because most of you are like uh, vexed with what I've taught so far. So let's get back to the application, guys. Now, yesterday Manjunath has took almost like 1.5 hour to 1 hour, 1 hour 45 minutes to discuss only on this respective schematic, guys. Correct? So now we will try and draw it in 10 minutes. Shall we? Right? So there is another application called AutoCAD Electrical, which you can see it here on my screen. Okay. It is the look and feel of AutoCAD Electrical is exactly like your normal AutoCAD, but we will also see how it is different, guys. We will also check how it is different. You can see that your respective home and all those are same, but here your respective electrical CAD or ECAD has this different sets. Except for your, apart from your home consideration, I could see that most of the project schematic panel reports, import export data, electromechanical, all these are different in case of your AutoCAD electrical, or I will refer it as an ECAD, guys. Okay. Yes, not only schematic J, it is also with respect to your project. So you have to define a project in this case where you will create a project for the list of the sheets, because you will create a panel and a schematic in case of your ECAD. Then we have schematic where you will create and you can generate a building a schema by it as. Uh, sure, Tejasvi, I'll explain on it. And then we have panel. So panel where you will talk about the panel design of it as in GA consideration. Then we have reports to generate the reports. In this AutoCAD electrical is a sort of simulation software, guys, because you see there is an option called electrical audit. Electrical audit wherein you will check with the connections whether connections are proper or not. That is called as electrical audit, where you can check with the defective wires. If in case any circuit is looped in, you can check all those connectivity checks also in case of your electrical audit. In drawing audit, you can check with respect to your wire numbers if you have given any duplicate wire numbers or any other segments also. Okay. And then import and export data, where you can check your respective project and import it from other different Autodesk tool sets. Electromechanical is a combination with respect to your electrical linking with your mechanical. In case of your oil and gas industry, we link our electrical and mechanical segments. So that will be used in this case of your electromechanical segment also. So quickly, I'll go back to schematic to show you like how this respective drawing will be drawn in a very simple fashion, guys. Let us see how it has been drawn. Let me go back to AutoCAD electrical. So I'll choose a wire. Okay, instead of it, I'll choose a bus. So what I'll do, I'll draw uh, a horizontal and then I'll click an empty space. Okay, guys, I'm not going to talk about I just wanted to give you an understanding about how AutoCAD electrical works and how your uh, applications are become making your work more easier. Okay, in AutoCAD, you cannot identify a mistake by just drawing it. Okay, right now I'll click on three numbers, right, and then I'll click on empty space in the horizontal. Now I'll click on this thing. Let me draw it. So, okay, I'm just entering. So I'll just give you a very basic example of how this ECAD and then your normal CAD runs. In case of your AutoCAD, okay, if I draw a line, what's the command for line command, guys? Right, L enter. Now you see that if I have to cross one line, a horizontal line with a vertical line, I'll take a circle. What's a command for circle? What's a command for trim? This is called as jumper, guys. Okay, in the electrical segment, what we do when we have two respective cross lines observed, we try to put a jumper there. Okay, now I took almost like 2 minutes to draw it. In case of your AutoCAD electrical, if I have a wire drawn like this, and then again I'm drawing a vertical wire like this. Okay, I'm using a wire, guys. Now you see that automatically there will be a jumper. So you will not have to look into very miniature things in case of your AutoCAD electrical, guys. It will make sure that it is being done by default. Okay. Now if I have to take one more line like this, if I'm having a line and then I have to draw a line like this. See, in the AutoCAD electrical, you can draw a normal CAD also. I'm just drawing a line. Give me a moment using my ortho on. Okay. Functionify, L enter. Okay. So guys, somehow I'll do it here. So in case of your line, I'll just use my yeah. Okay, now I have to take an offset. Let me take an offset with a distance. Okay, and I have to draw a vertical line connecting to this respective point. I'm drawing it like this. And then you have to always use a jumper. And then here you have to use a donut command to show that there's a connection between given inner diameter 0, outer diameter 1. Place it here. You can observe that there is a donut connected here like this. Okay, this is all in normal CAD, guys. When you are looking into an AutoCAD electrical, okay, let me show you that. You can draw a wire like this. Okay, and then you want to use another wire. I'll connect it irrespective of the distance considered, but I'll just draw it. This is one way of drawing individually a connection, guys. Okay, but if you want to draw a multiple bus, okay, I want a horizontal multiple bus. Okay, in empty space, and then the number of wires I want are 3. Now we have seen a 4-wire system. Let's click 4 and then select that. Click OK and then start point. I'm sorry. You can see that. Zoom in and I'll draw it again. Multi-bus. Okay, 4. Click OK. Start point, and then can you all see it, guys? I'll just stop it here. And now I'll take a vertical lining, guys. Okay, the spacing between them is 1. Let me take a vertical lining. Okay, I'll take empty space to another bus. Okay, and then again I'm taking 4 into consideration. Okay, start from here. Can you all see it? Automatically the connectivity is being shown from the existing connection, guys. Yes, we do have it. For every respective command, you have to use AE in between. AutoCAD electrical, AEW. AEW is AutoCAD electrical wire. I'm not showing you with the commands currently. It takes really a lot of time to understand the application and commands. Again, we need a separate session on it, but we just wanted to show you like how the connectivity is being given. Okay, now you can see automatically the connectivity is being seen and the jumpers are being formed, guys. Please observe the difference. Okay, I'll just take 1 minute of time just to show you like how components will be there. There's something called icon menu here. Okay, now if I want to use a push button or I want to use a fuse unit. Okay, I've opened this and currently we are using an American standard NFPA. right? And I'm using a fuse. Let me use a 3-pole fuse with tags. Click it, place it here. Down, I click it. Then automatically you give a connection line 1 as in 1, or else I can give you directly here 1. Okay. So automatically this is all one fuse unit. Or you want to separate it individually, you can give a name. Now you can see the equipment name is FU1. You can give a different tag also. Yeah. Now you can see that I'll use a breaker here. Let me click a icon menu again and go back to the breakers. Sorry, I've used it got double clicked. Going back to icon menu, click on this. You see separate breakers you place and use the 3-pole breaker and I'll connect it here. And it's down. And we are using only one breaker, 3-pole breaker. So it is CB1. All connected together. Okay. Now if I want to use a, what else we can use? We can use a contactor, of course, or we'll use a push button. Okay. Let me use an NO push button, placing it here to this. Okay, PB1. Like this. It's just that drag and drop, select the icon and place it into your respective position, guys. It is similar to Simulink, correct, correct. But the UI would be in the similar to your respective Simulink, but it would not be same as in Simulink because you are working on the respective what on the electrical considerations, right? And you're designing a scheme here. So something like this. Okay, now if I want to connect a motor to this point, let me go to icon menu. You will see a motor circuit option, motor control option, and you want a 3-phase motor here. Choose it, place it on the center, guys. Okay, and now I want to write as a motor 1, and then item 1, count 1. Click OK. Okay, so now you can see automatically the motor has been connected to the 3 respective terminals. Can you all see it? Guys, you will get your attendance link. You can, sorry, your feedback link. You can get that. Okay. My HIW team, could you please post the link on the group? Most of them are waiting and they're very eager to fill the form and leave. Okay. Did we all understand how this is being done, guys? So it's easy, and then we can see that almost most of it, and you want to add an overload relay, we can add an overload relay too. So you can see there's an option called relays and contacts. Okay. And then you want to add an steady state. Just give me a moment. Here I saw in motor control, you will see an overload relay. Breaker and disconnectors. So these are all breakers. Let's go back to these units. I'm just trying to find the overload relay. That's here. So we'll place it here for timing, just to show you people. Overload relay 1. Can you all see it, guys? Yesterday we have used 2 circle commands, 1 mirror command, and then we have also worked on the various terminals and circle commands, and then we've used trim command to work on the various segments that are being considered, right? Yes or no? Right? So we will always consider that and we will work on that. Are you all clear with this? Did you all understand electrical, AutoCAD electrical? Please give your valuable feedback, guys. Link has been shared on the chat box. Any questions? Right, did we all understand? So like this, we'll be doing it, guys. The benefit of ECAD is that you draw it, you can check it, the connections have been in. Uh, Actually, increasing your respective symbol size. We can scale it a bit, Abdul Moeed. Yes. You can install Vamshi Krishna. You can use it in, you can even install AutoCAD. There's an AutoCAD mobile application available that can be installed, which is available for Apple versions also. So with this, we have understood, and as in my starting statement, which we have discussed about AutoCAD from the history till the respective AutoCAD, drawing AutoCAD in various stages like an SLD schematic, and then we have seen how AutoCAD electrical is also being seen to make you guys understand the respective pin numbers and ferrule numbers. We were talking about wire numbers, so let me click a wire number and I'll give a tag to it for the. So you can use this. Okay, if I have, let's say earlier we had K1, K base, and then 1, L1. You can see it. Now, for example, it is fuse, right? So F, I'll put it. You can see the wire numbers defined it. Click OK. Start from here. So FL1, FL2, FL3. Did you all see this, guys? This is called as ferrule numbering. Somebody has asked me about ferrule numbering, which is, I think, Tejaswini Kulkarni. Right? We will be looking into the ferrule numbering, guys. Every connection will have a label to it, guys. Okay, that is called as your wire numbering. Now, similarly, suppose I'll give you for breaker. So I'll make it as CB line 1, and then I'll make it here. Line 1. Can you see it? It has been seen. Okay, CB line 2, line 3, okay, right? And then you want to add another one for here, or you want to have the second side. You can see that you'll have it here. Okay. So when you're connecting it here respectively, you will see the ferrule numbers according to the requirement. You want to change it, double click on it. You can change the respective wire connection according to the requirement. If you have any wire connection to be changed separately, you can change that also. This schematics can also be given as in PLC drawings also in the later versions. You can consider those also as in part of your schematic. Motor one symbol is too small, but in SLD we have got a bigger circle. Guys, I can also show you one more thing where we can directly draw an circuit builder, which is called a circuit builder. I'll just show you. And yesterday we have seen an vertical three-phase motor supply. Let us insert that and show you here. The same thing which we have drawn it and is seen here. Can you see it? Automatically, the one which Manjunath has taught you yesterday is this only, guys. It is generating. You can see it automatically. The whole drawing is been done. Now you can give the names to it. Switch disconnector. Simply there's contactor, there's an overlar, there's a terminal block. Again, there's a switch for the motor, and then you have a motor rating. Now you can give the names. There's a control transformer you have drawn, and then units, disconnector, push buttons, overload relay, and then you have your different push buttons. So that is simply a circuit builder that you can design it, and you can edit this to make your respective circuit work it on. That's how you can use your ECAD application in a very detailed way, only to draw specially the schematics and understand it in a better way. Are we all clear, guys? Any questions in this? I hope we have got a good understanding and drawing the a schematic in the normal CAD, and it took us almost like 2 hours, 1.5 hours. And now we are talking about a schematic drawn in just a fingertip. just in 2 seconds to 3 seconds, right? So this is something which we see as a very different manner in terms of your building construction. You want to draw a separate segment like this, you can draw it on your own also, if you have a clear picture like how this has to be done. Else, you can also draw it in a simple fashion. That's how your AutoCAD electrical will help, or ECAD will help the engineers to make their work faster and build the accurate and precision wise and good schematics and schemas to make sure that it is error free while doing in or implementing in the real time, guys. That's something about AutoCAD electrical. On this note, I would just like to tell you guys that we have a batch starting in the this month, guys, where we will teach you all these segments in detail to understand in a better fashion. Okay, we have a 2 months job oriented course where we'll be teaching you in detailed topic on AutoCAD, ETAP, E3, Dialects, PVSys, Google SketchUp, all these 7 softwares along with Revit. And also we'll be training you on 5 segments like your switchgear panel designing. All these AutoCAD so far we have discussed more majorly on switchgear panel designing. And then we will be learning about substation designing. Okay, we'll be learning about automation. We'll be learning about the industrial automation. How you automate the respective existing systems, or the new systems SCADA implementation will be learned. And then along with that, you'll be learning EV technology, which is booming in the market. So we will be giving you a complete 2 months course duration where it is a job oriented course duration. Once you get trained, you will be placed into the companies, guys. It will be online as well as offline, guys. You can take the course online as well as offline. Fee structure, you can contact our team, guys. You can follow us on our Instagram, YouTube, and LinkedIn handles to get more information. We will be taking the sessions. Me, Madan sir, Manjunath, we are all the core team of HIW. There will be other trainers also from the industry experts will be coming and taking the training sessions in detail on the topic. Yes, we can design house wiring with ECAD, but generally house wiring is done in Revit. Okay, the schema can be designed in AutoCAD or in the ECAD frame side. Yes, Satyendra, you can contact our team. I request my team to put the numbers for these people to understand. You can register on the link. Our team will get back to you. The details have been posted on the group, guys. If you have any electronic friends, we do have a batch starting on VLSI on July 21st, along with electrical, where that is a 6 months course duration, guys, where we'll be talking purely on VLSI. You can refer them also. That's also a job-oriented course program. Uh, any other questions, guys? Anybody who hasn't, give your feedback form. You can please do fill the link for more details. Okay, Saujanya, what you do is you put that text in this your feedback link when you're filling the feedback link for today. We will consider your request. If you have missed any of this, ma'am, actually I'm working for a solar site engineer, but I want to shift designing field. You can do it, Snehit. You can take training where we'll give you a detailed plant configuration design training in terms of solar, where you'll be looking into PSys and Google SketchUp, and you can look for a job. Your solar site experience will give you a better understanding, and you can become a better design engineer in terms of solar design also. If you want to look for another design, you can also look into it. We can meet in person and then understand, or you can call us on our numbers. Our team will get back to me and we will help you with respect to your shifting of into a design field, Snehit. Which course are you provided? We will be providing electrical system design course for electrical engineers, VLSI course for electronic engineers, Lavanya. Sai Teja, Venkat Teja says, is the course compulsory job placement or not? It is in, see, HIW has 15 years track record, guys, and almost every respective batch out of 50 plus P students, almost 45 plus 90 to 95% of these students get placed, until the 5% are looking only for the skill upgradation. We are full-fledgedly working into our complete course in terms of it. Okay, Teja, I think I answered the question. Okay, Saujanya, we'll look into your query. Don't worry, guys, if anybody has missed it. Okay. Yes, the courses for triple E in electrical system design. You don't need to leave the job, Snehit. You can take the course simultaneously, and then we will let you look into your respective other profiles. But it can be done from site, right? You can do it into it also. Okay, Sneha. We will get the certificate. Yes, you will get the certificate of 5 days. If you've attended all the 5 days and you have your respective name in all the five feedbacks, you'll be considered. Anybody who missed out, you can please mail us, and you missed in that case. We will consider your request, but not everybody. You have to attend all the at four and one missing. We will consider in that. And your certificates will be reached. Please do wait for a week time, guys. We'll get back to you in a week. Okay. Yes, Shalu, you can't get the certificate if you have missed any of the day. We'll look into your concerns, guys, and this is not the place where I can help you with this your certificate concern. You can get back to our team. Our team will come back to me, and then we'll see how your certificate to be issued and all. People who have missed it, please come back to us. And I all the 5 day recordings will be on available on our YouTube handle. You can come back to that place and you can see. We will share you the soft copy onto your email ID respectively. Okay. And if in case you didn't get it, you please check it in your spam folder also, guys. Anybody else? Guys, please do follow our HRW pages, and our details are being given according to this consideration. So guys, regarding feedback, I answered this question, so I'm not going to talk much on it. Our team will come back to you, Saiteja, regarding the price and details. You can contact our numbers, which will be shared on the WhatsApp, on the chat box already. Okay, we'll also put the same details in the WhatsApp community. If you are already available, you can please get back to that segment. You'll have more details in detail. Yes, you can leave for the day. Thank you so much, guys. Thank you so much. I hope you all had great fun learning with HIW and learned CAD as in as well. You can put this in your resume, and you can please play practice for making it, because when you put it in your resume, companies might ask you for a tool test, and you have to give a tool test if you put AutoCAD in your resume. Okay, please consider. Thank you so much, guys. Thank you for your all patience in understanding and your effort in learning electrical CAD and AutoCAD, and your interest in learning something in electrical. Thank you so much. All the best, everybody who has attended our session. We HRW signing off. Thank you. Please give your feedback on the link provided. Thank you.